These final three examples deal with arithmetic series. And if you remember, an arithmetic series is one where we've got the terms of a sequence added together. The first one here is a relatively straightforward one. It asks us to find the sum of 20 terms in an arithmetic sequence if the first term is 9 and the last is 99. So in a question like this, we've been told that the first term is 9, so this tells us that A is equal to 9. And we're told that the last term is 99, so in other words, L is 99. And in this particular problem, they've been very nice, and they've told us that there are 20 terms. That's going to be our number of terms. So with a question like this, all we have to do is use the sum to n terms formula. And the base formula of this was the sum to n terms is equal to n times a plus l divided by 2. And so for this problem, it's just a matter of simply substituting in. Okay, we have 20 terms for n. Our a, we said, was 9. Our L was 99 divided by 2. So that's going to be 20 times 9 plus 99 is 108 divided by 2. Could grab a calculator out, but we can actually be a bit smarter with this one. If rather than multiplying here, we actually do this cancelling first. 20 divided by 2 is going to be 10. And then multiplying by 10 is nice and easy, so we're going to get 180. So rather than have to add 20 numbers together mechanically, we can simply use this formula, and in 3 steps we can get out an answer for this sum as being 1080. This next question is a little bit different to the last one. The main difference here is it hasn't told us what the last term in this sequence, or what, in other words, what the 12th term is in this sequence that we've got to add up to. It's just given us the start of the sequence and told us we need to work out 12 terms. So the regular sum to n terms doesn't work in this case. Okay. We can't use it because we don't know what this L is here. So what we're going to do to solve this is we're going to modify the formula just a little bit. We're going to get rid of this L term. Now, the last term that we're adding together has to be the 12th term in the sequence. Okay, in this particular sequence, L is going to be term number 12. And we can work out what term number 12 is because this is an arithmetic sequence. And the nth term in a particular sequence is normally a plus n minus 1 lots of d. N minus 1 in this case is 11. And d, what's our common difference? Well, if we look here, the common difference in the terms is 8. And I've put an a in there when in fact I should put in a minus 14. So if we work that out, minus 14 plus 88. Minus 14 plus 88 is like 88 minus 14. So minus 10 would be 78, minus another 4 would be 74. So that is the value that we are going to substitute into here. So the nth term is the 12th term, n is 12, a is minus 14, and last term is 74. And finally, let's simplify this a little bit. 12 divided by 2 is going to be 6. Here, 74 minus 14 is going to be 60. So I'm going to get 6 lots of 60 is 360 as my final answer to this problem.